For this video, we're going to take notes on continuity and boundedness. So first, we're going to start with continuity. A function is considered to be continuous if you can draw the entire function without picking up your pencil off the graph. If you're given an actual graph and not an equation, you want to try tracing that graph. If you can trace the entire function without picking up your pen or pencil, then it would be considered continuous. A function is discontinuous if there is a hole or a break in the graph. And we'll take a look at examples in a minute. So if I have to pick my pen up because there's a hole or pick my pen up because there's a break, the function is discontinuous. There are actually going to be different types of discontinuities that we're going to focus on. The first one is considered a jump discontinuity. The second is a removable discontinuity. And the last is an infinite discontinuity. So here are some examples. We're going to identify any discontinuities in the graph, and we're going to be as specific as possible. So let's take a look at number one. If I go to trace my graph, I can't continue tracing. So there's definitely a discontinuity. If you notice, there's an asymptote drawn in here. So when we have asymptotes, that's considered an infinite discontinuity. And I want to be specific, so I'm going to say at x equals -3. Then I pick back up and I continue tracing. There's a hole here, so that's what we call a removable discontinuity. And that's at x equals 0. So there can be more than one on the same function. Example 2, if I trace my graph, I never have to pick my pen or pencil up, so this function is continuous. Example 3, you may notice it right away. If you need to trace it, there's a hole, so this is a removable discontinuity. At x equals 3. Lastly, example 4. This is what we call a jump discontinuity. At x equals -1. If I'm tracing my graph, it jumps up and continues there. It's not infinite because there's no asymptote. So slight difference between a jump discontinuity and an infinite discontinuity. So there are 4 examples for you to try on your own. You can either pause it now and try them, or finish the video, scroll down, take the rest of the notes, and then come back to it. Our next set of notes is about boundedness. So a function f is bounded below if there's some number b that is less than or equal to every number in the range of f. Any such number, b, is called a lower bound of f. This is a fancy way of saying that our function has an absolute minimum, or an overall minimum. So if we have functions that are bounded below, we also have functions that are considered bounded above. And a formal way written out in your definition here, if there is some number b that is greater than or equal to every number in the range of f. That means our graph has an absolute maximum. And then a function is considered just bounded in general, not above or below, if it's bounded both above and below. So there are really 4 options. So the other option would be it's considered unbounded if it has no maximum and no minimum, but that's not in your notes. But you could add that if you'd like, the definition of unbounded. And then here are 4 examples for us to look at to comment on the boundedness of each graph. Example 9, this graph has a bound here. It has a minimum at the point 2, 0. It never goes below that point, so this is bounded below, with our minimum being y equals 0. Number 10, notice, is a polynomial function. It has arrows in both directions. It has no maximum and no minimum, so it is unbounded. 11, you should notice there is a maximum value here. Our vertex is at the point -4, 3. So this is bounded above. If they asked for a specific y value, it has a maximum at y equals 3. And then lastly, number 12, this is an oscillating function. It looks like your sine or cosine function. It's bounded above at 4 and bounded below at -4. So it is just bounded, not above or below, because it's bounded in both spots. It has a minimum at y equals -4 and a max at y equals +4. And there are 4 questions for you to try again on your own. And remember, you had to do those 4 continuity questions as well.